Okay, so the questions I had asked you to try were on page 110, 21, 22, 24, 25, and 27, I believe they were. So number 21, a kayaker paddles upstream in a river at 3.5 meters per second relative to the water. So the kayaker is going this way. So this is V of the kayaker, 3.5 meters per second. And I'm going to put a US after it, meaning upstream. Okay? Observers on the shore note that he is only moving 1.7 meters per second upstream. So he's paddling 3.5 meters per second. But people on the shore only see him going 1.7 meters per second upstream. Now, why would that be? Well, hopefully you're saying it's because the water must be working against him. The water's flowing downstream. So the 1.7 meters per second is his velocity with respect to the people standing on the bank. Okay? And so they see the resultant of him paddling upstream and the water pushing back on him. So what must the water be doing in order for his final velocity to be 1.7? Well, it has to be the difference. It must be 1.8 meters per second, and it's going to be downstream. Okay? So that's all you need to do for that one, because they're going opposite directions. You can just subtract. Number 22 is a little bit different, because this time a jet skied across a river relative 11 meters per second relative to the water. So here's my river, and it says the jet ski dude is going south, so he's going this way. And it says that the river is flowing west. Of course it is. So the river's flowing this way. So this is the V of the jet ski, and it's 11 meters per second south. And this is the V of the river, or the water, and it is 5 meters per second west. So the buddy on the jet ski just wants to go directly towards the opposite bank, but the water has a different thing in mind. So the water's going to be carrying him to the west while he's trying to cross. So his resultant velocity will be this one. Okay, so this is what the jet ski is doing with respect to the shore, the land over here, what someone would see him do. It's always the resultant, and it's always what he's doing with respect to the water plus what the water's doing. Well, because they're at right angle triangles, we can find what the jet ski is doing with respect to the shore. It's just going to be Pythagorean theorem. So it's going to be 11 meters per second squared plus 5 meters per second squared, and then take the square root. So the speed of the jet ski with respect to the water should be because I think this works out to be 25 to 146, the square root of 146 meters squared per second squared. So this will be 12.08 meters per second. But remember, this is a vector, so we need a direction. So we need to find this angle. And we can, because we have the adjacent side and we have the opposite side, so we can just do tan. So tan theta will equal 5 meters per second over 11 meters per second, opposite over adjacent. And when you do inverse tan of that, you should get 65 point, oh, I think I did the other one. Sorry, let me try that again. It's 5 over 11. I think I did 11 over 5. Yeah, it's 24.4 degrees. 24.4 degrees. So then we have to go square bracket. Which way am I measuring off of? The south. 24.4 degrees. Which way did we turn? West. So the answer to number 2, the question was, determine the jet ski's velocity relative to the shore. It's 12.08 meters per second south, 24.4 degrees west. Okay, so that's number 22. Number 24 says an airplane travels due to north for 100 kilometers, then west for 150, and then south for 50. So you don't have to draw these ones to scale because we're going to do mathematically. So it's traveling north 100 kilometers, and it's due north. And then it's traveling west for 150. So 150 kilometers west. And then it turns and goes 50 kilometers south. Okay, so your diagram should look like this. Your resultant is going to be here, starting where the first one started, ending where the last one ended. Now you might say, how am I supposed to find this? This is not a right angle triangle. But if you look, it really kind of is, right? Where this side is 150 kilometers west. And this side is just the 100 kilometers north minus the 50 kilometers south. So it's really 50 kilometers north. And now you can do Pythagorean theorem to find this side. Okay, so if we call this the displacement d, it's going to be equal to the square root again, Pythagorean theorem, 50 kilometers squared plus 150 kilometers squared. And then, of course, take the square root. And when you do that, you get a d to be 158 kilometers. 50 squared plus 150 squared. I'm just checking on the 158.11. And I kept 3. I really probably should have kept 2, but I'm keeping 3 because I don't want to round it to 160. Of course, we need an angle, and the angle would be down here. And so, again, we have the opposite side, we have the adjacent side. So it would be tan theta is equal to 100 kilometers over, this side is just 50 kilometers. And it's 150. I keep doing 100 because I keep missing. Okay, so inverse tan of 3, because that's what 150 divided by 50 is, gives us 71, although I don't know if it asks for that. Find the total displacement. It does. Okay, so it's going to be, theta is going to be equal to 71.57 degrees. So then we would go here. Which direction are we measuring off of? North, 71.57 degrees. Which way did we turn? West. And this is the answer to 24A using, oh, it's actually the answer to 24B, 24A, but we didn't use vectors. So then it says the time for the airplane to fly the 3 different parts of the trip are 20 minutes. Let me switch back. So T1 is 20 minutes. T2 is 40 minutes. It's telling me this in the question, in case you're wondering where I'm getting them. And T3 is 12 minutes. And it wants to know, calculate the velocities for each of the 3 segments. So VAV1 will equal delta D1 over delta T1. 100 kilometers over 20 minutes is 1/3 of an hour. So 1/3 of an hour. So this will be 300 kilometers per hour. And it was going north. So this is part B. VAV2, delta D2 over delta T2 is 150 kilometers. 40 minutes is 2/3 of an hour. And I'm using the fractions because the decimals are repeating. Flip it, make it 450, divide. So this is 225 kilometers per hour, and it was west. And then number 3 was 50 kilometers per hour in 12 minutes. So VAV3, delta D3 over delta T3. 50 kilometers over 12 minutes. 12 over 60 is 1/5 of an hour. And so this will be 250 kilometers per hour.